Welcome to the video about the history of the periodic table. We're going to be talking about in class some of the features of the periodic table, but I'm going to talk to you about how we got the periodic table. So we've talked about the history of the atom. We know how we started with the whole earth, air, fire, water thing, and that was like bogus. And so they went and figured out that matter is made of atoms, and then they figured out that the atoms are made of protons and neutrons and electrons. But then we had all these atoms, a bunch of elements, and they need to organize them. So up until this guy, Dmitri Mendeleev, they were just writing lists of atoms. But he started saying, well, let's organize them a little bit more to show even more of the information that we know about them. So he was doing his work in the mid-1800s. So if you recall from your timeline, Dalton had his atomic theory in the beginning of the 1800s. Protons, neutrons, and electrons were not discovered until the end of the 1800s. So this guy, all he knew was what Dalton had to say. So if you went back in time and you asked Dmitri Mendeleev, of course you'd have to go to Siberia for this, which I don't recommend, but if you asked him to draw an atom for you, he would draw Dalton's atom. So a solid, indivisible atom. Here's what he knew. They had discovered 60 elements by then. We have over 100 elements now. So we had, about almost 2/3 of what we know. And he also knew relatively how heavy these things were. He knew that carbon was 12 times heavier than hydrogen. And he knew that calcium was 20 times heavier than hydrogen. So they knew the relative atomic weights of these little supposedly solid indivisible marbles. So then he wanted to arrange his elements by weight and reactivity, because what he noticed was some elements react the same way. So instead of just making a list of atoms, being like, okay, here's hydrogen, here's its weight, here's helium, here's its weight, so on and so forth down the row, he said, let's put all the ones that have the same reactivity, let's put those in the same row and see what happens. And so he created a periodic table, and I'm about to show you what his periodic table looks like. I'm going to bend the camera. And so I've got an example of his periodic table here, which is upside down. Okay, so on this periodic table, which is basically a copy of his, you see hydrogen here, and then you've got lithium down here, and then beryllium and boron and carbon and nitrogen, oxygen, fluorine. So you can see by these numbers are the atomic masses. And we know that the atomic mass now is made up of protons and neutrons. He didn't know that because he didn't know anything about protons and neutrons. But he knew that this was their mass. And you can see that the masses decrease as you go down. So atomic mass, increases as you go down the periodic table, according to Mendeleev. This is Mendeleev's periodic table. And the way he organized them in a row is he said all the ones in the same row have the same reactivity. So, for example, he knew that lithium and sodium and potassium, rubidium, cesium, he knew that all of these will react explosively with water. That if you put one of these in water, it will catch on fire. And we've already talked about that in class. So he said, okay, they have increasing atomic mass as you go this way, because we go down and then down and down and down the list for atomic mass, and then they have the same reactivity going this way. The beauty of this was after he made this table, he had these question marks, like here and here and here, and he knew that there was a hole in his table. And he knew that it had to, whatever element was here had not been discovered yet, but it would have a mass of about 68, and it would have a mass of about 70 if it was in this hole. So it's basically like, let's say that you had a deck of cards and you knew that some of the cards were missing. You could lay out all the cards by suit and by number, and you could find exactly which ones were missing. He did the same thing. He didn't know the names of the element, but he knew exactly what kind of reactivity they have. He said, well, this element should react the same way as aluminum and boron, and it should be heavier than aluminum, should have a mass of about 68. This one should react the same way as carbon and silicon and tin, and it should have a mass something around 70. So the excellent thing about Mendeleev making this periodic table was his ability to predict the existence of new elements. So he had the ability to predict the existence of new elements. And as the years and decades unfolded after Mendeleev's periodic table, lo and behold, they were able to find new elements, and they fit them exactly in Mendeleev's table. And it's a heck of a lot easier to find something once you know what you're looking for. Okay, so back up to the board. Let's talk about the modern periodic table. So there's the board. And it's upside down, and nobody wants to look at that upside down. Okay, so here's the modern periodic table, an example like you have in your star sheets that I handed out. This one was put together by a guy named Henry Moseley in 1913. So if you go back to your timeline and figure, okay, what did we know by 1913? They found protons, because Goldstein did that in 1888. They found electrons, because J.J. Thomson did that in like 1897. They had not yet discovered the neutrons. Okay, Rutherford had done his bit with the nucleus, but he only thought that the protons were the nucleus. So at this point, they knew about protons and electrons. They did not know anything about neutrons. So he decided with this new information of protons that he's going to arrange his periodic table by protons. And so that's what we have here. This is the atomic number. Hydrogen is atomic number 1, helium is 2, lithium is 3, so on and so forth. So hydrogen's, so his atomic numbers go like this. So it increases across the periodic table, and it goes down to the next level, increases, increases, increases. So every element is one more proton than the one before it. And then he put reactivity actually in columns. So he turned Mendeleev's periodic table 90 degrees. So here's same reactivity here. So here's the same list. Hydrogen, lithium, sodium, potassium, rubidium, cesium, all of these guys will react explosively with water. And this is the way we have our periodic table set up nowadays. It's a lot easier because in some cases, because of the neutrons, you'll have two things that'll actually have the same atomic mass roughly, or that will actually be inverted. Like in here, if you look at your periodic table, you see that even though the number of protons is increasing, the atomic mass has a little hiccup and goes back. Well, we now know that atomic mass doesn't really mean a whole lot unless you're talking about nuclear radioactivity. But as far as how the things react, it's not really based on the atomic mass. So it's much better to have our periodic table organized by atomic number. And Moseley was the guy who did it back in 1913. Thank you.